The third area is the use of synthetic polypeptides. These are materials that we make in lab that are designed so that we have an amino acid sequence in our polymer chain. However, the amino acid sequence, rather than being built using biological machinery, is built using a polymer synthesis technique in a flask. Now, these polypeptides are ones which we've designed to be able to be modified using a very, very effective kind of chemistry called click chemistry. The idea is that the polypeptide backbone has a group hanging from each one of the amino acids in it that allows us to do a very rapid chemical transformation and introduce different chemical groups so that we can decorate that polypeptide backbone with a range of different functionalities. Right now, we're looking at whether or not we can mimic different kinds of biomaterial functions. This includes trying to recreate the natural antibacterial capabilities that the body has developed and a number of organisms have developed. They're called antimicrobial peptides, and there are a number of natural ones that exist, but they're very expensive and it requires a large amount to actually have any effect. So we're trying to see if we can design a polymer substitute for that can be made in the flask in large quantity and can actually be an antibiotic that does not allow the development of resistance. So this is one of the areas that is very intriguing to us, because if we can get a little bit more like nature in the way that we address the attack of antimicrobial systems, then we can actually develop a system that may not have some of the downsides, which is that we ultimately develop resistant organisms. In this approach, what we're trying to do is to design a synthetic polypeptide that contains the same kind of functional groups that a natural living organism develops that can kill in invading bacteria. And we're finding that it is possible to replicate the killing capability of bacteria using this clickable approach, and that we can design these systems so that they're safe in the body. Now we're trying to enhance the efficacy of those systems. If we're able to do that, then we may be able to develop a system which kills bacteria in a way that doesn't allow them to stay behind and develop a resistance against the drug.